Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will look at equations with pronumerals on both sides. So when I say that, I mean on both sides of the equal sign. We've got a pronumeral or a letter on the left and right-hand side of the equal sign. So the idea here is similar to what we learned last lesson. When you have the pronumeral in more than one spot, you must first get it to one spot so that you can then undo what's been done to it. So in order to do that, we're first going to expand any brackets or get rid of any fractions. Then to get x to one spot, we're going to subtract from both sides the pronumeral with the lowest coefficient. After you've done that and x is in one spot, you can just solve as normal. Okay, sounds a bit complicated. Let's try on this one here. Well, firstly, there are no brackets or fractions here to get rid of, so we can go straight to step 2. We have x at more than one spot. We can't solve it yet. We need to get x to one spot. When you have the pronumeral on the left and right-hand side of the equal sign, we are going to subtract the one with the lowest coefficient, and that's this one here. 3x has a coefficient of 3. 3 is obviously less than that coefficient 5. So what I'm going to do is I'm going to subtract 3x from this side because 3x and negative 3x undo each other. You just get 0. But again, what you do to one side, you must do to the other. So I'm going to subtract 3x from this side. See, in doing this, I'm going to be left with 7 equals, now 5x minus 3x is 2x. And I've still got the negative 7 there. Note, these two are not like terms. You can't subtract them. See, I've reduced this to an equation where x is in just one spot, so we can use our normal methods to solve. Step 3, I'm just going to add 7 to both sides and divide each side by 2. I get x equals 7. That is the solution to this one here, because if you substitute x for 7 here and here, you get a true statement. You get 28 equals 28. We're done. All right, let's try this one here. Once again, pronumeral on both sides. There are no brackets or fractions to get rid of. I'm going to go to step 2. We need to subtract from both sides the pronumeral with the lowest coefficient. So here the coefficient is 7. Here the coefficient is not 4, it's negative 4. So the way I'm going to get x to one spot, I'm going to subtract negative 4x. I'm going to subtract this one because it has the lowest coefficient. Of course, what you do to one side, you must do the other. Now, you probably realize that subtracting a negative is the same as adding. I'm adding 4x to both sides here because it will get rid of the x on this side. I will be left with 10 on this side. And on the right-hand side, 7x plus 4x is 11x. So I'm left with an equation in which the pronumeral is only in one spot. I can solve like normal. I can just add 12 to both sides and then divide each side by 11. I get x equals 2. That is the solution, because if I substitute x for 2 here and here, I get a true statement. 10 minus 4 times 2 is 10 minus 8, 2. 7 times 2 minus 12 is also 2. I know this is the right solution after checking. All right, let's look at some harder examples now. So let's look at this equation here. Now, it doesn't look like x is on both sides of the equation, but we can easily turn it into such an equation. See, what we can do is cross multiply. We multiply this by this and this by this. That's what it means for fractions to be equivalent. This times this equals that times that. So in doing that, what we're going to get is 4 lots of x minus 5 is equal to 3x. So this is an equation now with pronumeral on both sides. Now we do have brackets. So step 1 on the previous slide tells us we need to first get rid of any brackets. So we do that by expanding. 4 times x, 4 times negative 5. Okay, now we are going to subtract the pronumeral with the lowest coefficient. It's this one here. This coefficient's 3, this is 4. So from both sides, I'm going to subtract 3x. So of course 4x minus 3x is just 1x, or x. I'm going to leave the negative 20 alone because these two are not like terms. 3x minus 3x is 0. So I've got x subtract 20 is 0, and that means x equals 20. Okay, and that's true because 20 over 15 does equal 4 over 3. All right, let's try this one here. That's pretty hard. So we have fractions with pronumeral on both sides. So our first step, we're going to get rid of the fractions. So let's get rid of this fraction here by timesing by 7, because times 7 and divide 7 undo each other. But when you're multiplying this side by 7, you have to multiply the whole shebang. So I'm going to multiply that by 7. When you multiply a fraction by a whole number, you just multiply the top by the whole number. So I multiplied this side by 7, so I must also multiply this side by 7. Again, multiplying fraction by a whole number, only multiply the top by the whole number. Okay, now I want to get rid of this fraction. So I'm going to multiply this side by 3, because times 3 and divide 3 undo each other. But when you multiply this side by 3, you have to multiply the whole shebang. I multiplied this by 3 to get rid of the 3, so too I have to multiply this fraction by 3. Now, if I multiply left-hand side by 3, so too I must multiply the right-hand side by 3. So I can just take this 7 and change it into a 21, because 7 times 3 is 21. Okay, now what I have is these fractions are gone, but I still have a fraction on the right-hand side. So what am I going to do that? I'm going to multiply each side by 4. So multiply 4, divide 4, undo each other. So I have to multiply this by 4 and this by 4. So I end up with 12 side of 10 minus x minus, so now I'm going to multiply this by 4, 28. Lots of 4 minus x equals 21. Lots of x plus 3. Okay. We've got rid of the fractions, but now we have brackets. We need to get rid of them. We do that by expanding. So I go 12 times 10, 12 times negative x. Negative 28 by 4, negative 28 by negative x. Negative times a negative is a positive. And I'm going to expand the brackets on the right-hand side as well. Okay, so let's collect like terms. 120 minus 112 is of course just 8. Negative 12x plus 28x gives you positive 16x. And then of course we have 21x plus 63 on the other side. So we have at least reduced it to an equation with pronumeral on both sides that has no brackets or fractions. It was a lot of work, but step 1 is complete. Now we're going to complete step 2. We're going to subtract the pronumeral with the lowest coefficients. That's this one here. From both sides, I subtract 16x. I'm left with 8. 16x minus 16x is 0. 21x minus 16x is 5x. So I've got 8 equals 5x plus 63. Now I'm going to subtract 63 from both sides. Divide each side by 5. I get x equals negative 11. So it was a hard question and a lot of work, but we solved it just by using the steps on the previous slide. Alright, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.